Hey everyone, and welcome to this explainer. Today we're looking at the silent guardian, the role of earth wires. We are going to unpack a really thrilling high-stakes mystery that's actually hidden right inside the walls of your own home and uncover the literally life-saving physics that protects you every single day. Let's get right into it.
Okay, let's dive into this, because I'm pretty sure most of us have experienced this at some point. Have you ever brushed your hand against the metallic body of an old refrigerator or maybe a vintage toaster and felt this sudden, terrifying little zap? You know, the kind that makes you kind of question if your kitchen appliances are secretly plotting against you. Or perhaps you've looked at the wall sockets in your house and wondered why your heavy-duty appliances like your air conditioner or your washing machine need a plug with 3 thick pins, while your smartphone charger gets by with just 2. Well, these aren't just random design choices. They're actually the front lines of a high-stakes scenario. But to really understand the danger, we have to understand the power. 220 volts. That number represents the immense electric potential difference flowing into your home's main supply right now. In many parts of the world, like India, this alternating current operates at a frequency of 50 Hz, which basically means it's changing direction 100 times every single second. To put that into perspective, this is an immense, invisible, and frankly highly dangerous amount of power. I mean, it's enough to easily power heavy machinery, boil water in seconds, and if it's not properly controlled, it can cause a fatal electric shock. So, to manage this 220-volt powerhouse, domestic electric circuits rely on a trio of specialized wires, typically running right alongside each other in parallel. Let's meet our cast of characters, color-coded by their insulation. First up, we've got the high-potential hothead, the live wire. This is usually wrapped in red or brown insulation, and it's the one actually carrying that 220 volts right into the house. Next is the calm neutral wire, wrapped in black or blue. It sits at 0 volts and simply provides the return path to complete the circuit. And finally, we have our resting protector, the earth wire, wrapped in green insulation. Now, just like the neutral wire, it sits at 0 potential, but its role is entirely different.
Now, a domestic circuit usually works perfectly, but let's look at what happens when things go wrong. Imagine an inciting incident, a fault in the system. Inside your metal refrigerator, there's a lot of wiring, right? Suppose the plastic insulation on that red live wire gets damaged. Maybe it tears, or actually, say it melts a bit due to overheating. Suddenly, that exposed live wire comes into direct physical contact with the metallic casing of the appliance itself. Instantly, the entire metal body of your fridge is sitting at 220 volts. It is effectively a giant live wire, just waiting for someone to touch it.
If you touch that fridge, the electricity will use your body to reach the ground. Not good. But this is exactly where our silent guardian, that green earth wire, leaps into action. You see, earthing gives that leaked current a low-resistance path straight down to the ground. The earth wire is connected directly to the metal casing of the appliance on one end, and on the other, it runs all the way outside your house to a metal copper plate buried deep in the earth. Because electricity will always take the path of least resistance, that massive current chooses to rush down the highly conductive green wire into the ground, completely bypassing you.
And this brilliantly illustrates the rapid chain of events that takes place in a fraction of a second to neutralize an electrical threat. Step 1. The fault occurs, and the live wire touches the metal casing. Step 2. Because the earth wire is already attached to that casing, it instantly provides a superfast, low-resistance freeway straight to the earth. Step 3. Because the resistance drops so incredibly low, a massive surge of current flows out of the live wire and down into the ground. And Step 4. That enormous spike in current triggers the circuit's main safety device, the fuse, which completely blows out, instantly severing the 220-volt power supply.
To truly appreciate what the earth wire is pulling off here, we need to understand a vital electrical concept, the short circuit. Basically, a short circuit happens when a fault allows current to flow without any real resistance in its way. Now, usually, this is a bad thing, like if a live wire and a neutral wire touch directly, causing huge currents, sparks, the whole shebang. But here is the absolute genius of the earth wire. It actually harnesses the physics of a short circuit to save your life. By offering 0 or negligible resistance to the earth, the green wire intentionally creates a controlled short circuit to force the system to recognize a major fault and shut down immediately.
The secret lies in the math behind the magic. Like, how exactly does this massive current force the system to shut down? It all comes down to Joule's law of heating. Power equals current squared times resistance. That squared part is absolutely crucial. Because the current is squared, even a tiny rise in electrical flow causes an exponential, massive explosion of heat. So when the earth wire creates that massive current surge, it instantly generates an intense amount of heat inside a very specific low melting point wire located inside your fuse box.
Which leads us to a beautiful piece of electrical teamwork. The fuse and the earth wire are the ultimate dynamic duo. The earth wire acts as the spotter, right? It detects the dangerous leak and uses its low-resistance pathway to summon a massive surge of current. Then, the fuse is the sacrificer. Sitting right there in series with the live wire, the fuse takes the full brunt of that massive, heat-generating current we just calculated. The thin wire inside the fuse literally melts, physically breaking the circuit. The power is cut, the appliance goes dead, and a catastrophic fire or fatal shock is entirely prevented.
So, the crucial point is this contrast right here. There's a very common misconception out there that the earth wire is actively carrying electricity all the time. But look at the difference. The live wire is the one constantly carrying the current to power your devices. The earth wire, on the other hand, normally carries absolutely zero current. It is completely dormant, just waiting patiently in the walls. It only ever carries current during an absolute emergency, acting strictly as an emergency escape chute for leaked electricity.
Let's actually look at how this exact physics is built into the very design of the objects we hold in our hands every day. Look at the anatomy of the standard 3-pin plug used for metal-bodied appliances. That top pin, that's the earth pin. Notice its physical characteristics. It's the thickest pin, meaning it can handle a huge surge of current without melting itself. But more importantly, it is the longest pin. This is just a brilliant piece of engineering. Because it's the longest, when you push the plug into the wall socket, the earth wire connects first, meaning your appliance is physically grounded to safety before the live power ever makes contact. When you pull it out, it disconnects last. Safety first, safety last.
The physics of electric currents and resistance aren't just abstract concepts in a textbook. They are meticulously woven into the fabric of our homes to keep us safe from an invisible 220-volt threat. The earth wire truly acts as a silent guardian in your walls, ensuring that a simple household fault doesn't become a tragedy. So, as we wrap up this explainer, I leave you with this. When was the last time you checked your safety net? Make sure your heavy appliances are using properly earthed 3-pin plugs, and take a moment to appreciate the incredible, invisible engineering keeping you safe right now. Keep questioning, keep learning, and I'll catch you in the next one.